how to take the derivative of this. So does anyone know what the derivative of this is?
Would it just be f prime of x squared?
Keep going.
Times 2?
Going. You're right. I mean, you kind of messed a part of it up.
Oh, times 2x?
There you go. That's it.
Is it like just doing chain rule but without anything else, so the constants would just get replaced with the f?
Absolutely. That's it. I mean, because that's what you're doing, right? Is the outer function is technically your f, right? So the derivative of your f is f prime, and then the inside has to stay the same, just like the regular chain rule. And then we multiply by the derivative of the inside. Does that make sense?
Yeah, that makes sense.
And the thing is typically what problems like this look like is what they're doing is they'll give you like a chart, and they're going to give you a chart of a bunch of different values. Like they're going to say g of 4 equals this, g prime of 4 equals this, and then basically and then they'll give you f of 4 equals this, f prime of 4 equals this, and then they're going to start asking you things like, what's g prime of 4? And then you need to plug in, oh, that means I'm going to have f prime of 16 times 8. And then they're on the chart, they would tell you what f prime of 16 is. Oh, f prime of 16 is equal to 2. Oh, 2 times 8 is equal to 16. Like, that's the kind of stuff that they would ask you to do on these types of problems. Are you guys following a little bit?
I am. I kind of feel like we've seen problems like that before, but I can't remember where.
Well, good. That's a good thing.
I mean, I guess. Yeah.
So you have 1 minus cosine of x over sine of x, but did you combine this one as well?
Oh, no.
Okay, so that's the issue, right? Is I have plus cosine of x here. So what I need to do is I need to combine this fraction into this fraction over here. So that means I've got to multiply by sine over sine. Does that make sense?
Okay.
So therefore, this would be the limit as x approaches 0 from the positive of 1 minus cosine of x plus sine of x cosine of x all over sine of x. Now we have to take the derivative, which sucks. So this would be sine of x, because this is just 0. Derivative of negative cosine of x would be positive sine of x, plus, and then we have to do the product rule. So this would be cosine squared of x plus negative sine squared of x still with me?
Yeah.
Okay, over cosine of x. So now you plug in 0 again. This goes away, this goes away. These can cancel out to be cosine of x. Cosine of 0 is just equal to 1. Okay, so what they basically want you to recognize is that if A is going to be 6, then that means that the limit as x approaches infinity would have to be equal to 3. So that is limit notation. That is using limits to show that A would have to be equal to 3. Well, here's the deal. The limit as x approaches infinity is equal to 3 because that's where there's a horizontal asymptote. That's the definition of a limit as x approaches infinity, is the horizontal asymptote. So because the horizontal asymptote is y equals 3, that means that the limit as x approaches infinity of f of x has to equal 3. Well, the only way for that to happen is if your leading coefficients equals 3. Does that make sense?
Yeah.
Okay. More importantly, for the second one, that is where limit notation is important as well. So, like, you have your answer as 6 times 2 minus 1 over, I'm not exactly sure what you have there.
I think this is 2 times 4 plus 4.
Yeah, but that doesn't equal 8. You should have 2 times 2 plus 2, which is equal to 8. 2.
Because x equals 2?
But x doesn't really. So the thing is you needed to show that you're doing the limit as x approaches 2. That's what they're looking for. How did you know to make it equal to that? Well, because you cancel things out in the limit, and the limit now, you're essentially removing the hole. So the hole is there because the x minus 2's cancel out, right? So because the x minus 2's cancel out, you now have to plug in 2 again. They need you to show that you're using the limits to actually show continuity. That's what this is about, right? You're using calculus to show this. And that's kind of the key there, is making sure that you're not forgetting that. Because this whole thing is dealing with limits. So if the whole thing is dealing with limits, then we need to use limits to explain ourselves. Does that make sense?
Yes.
So really, you're doing everything right mathematically. You just need to make sure that you continue to take the limit all the way through. Because that's what all of this is limits. But I mean, I understand why people do it that way, because they're not using the word limits in any of their questions. But they want you to use limits to explain how you're getting your answers. I'm going to say at x equals -2. You would figure out what the slope is. And then you do y equals 1/2 x squared minus 6, and then x equals 0. What's the slope? Y equals 1/2 x squared minus 6. X equals 2. What's the slope? Are you with me? So it's going to be like 1, 2. Good.
So I just put it into like the equation?
No, you don't put
it.
You don't put it in the equation. Obviously, you put this into the equation to figure out what your y value is, right? But you still need to figure out what the slope is the same way we were doing it above. So like up here, you might do, x equals -2.1, and then whatever y is equal to. And then find the slope between these two. Okay, then the next one, you'll do x equals -0.1, y equals, figure out what that is, and then find the slope between those two, okay? And then you're going to get your approximate slope of these. And what I'm telling you in this problem is you should, just for this particular problem, you should be getting the slope of -2. You should be getting the slope of 0. You should be getting a slope of 2. That's just what's going to happen in this problem. That's not what's going to happen in every problem, just this problem. Are you with me or no?
So I basically have to like make those charts for each value of x.
Yes, but do it very condensed. Don't do 6 values for each one. Literally do something very, very close on both sides of this. So like if I was doing y equals 1/2 x squared minus 6, and I'm doing x equals -2, here's what I'm doing. I'm going to do xy, I'm going to do -2.001, and I'm going to do -1.999. figure out what those two y values are, and then find the slope in between, you know what I'm saying? And then do your m. Find the slope between here and here. So this one is negative 2 squared is 4. 4 divided by 2 is 2. Minus 6 is negative 4. Okay, so find the slope between this and this. There's your slope. Find the slope between this and this. There's your slope. And then get an answer. Does that make sense?
Yeah.
Just don't do
And
don't
so-
do it with 6. Don't do it with 6 values. Just do it with the values that are closest to negative 2. The sign of 3x. And to get them to look like our special limits, I'm going to put an x here, and I'm going to put an x here. Because those two x's would just cancel out. We're not changing the problem at all. So we will be left with 3, and then the limit as x approaches 0 of this would be 4. And the limit as x approaches 0 of this would be 1/3. So that's 12 divided by 3. It's equal to 4. We have our other one, which is x sine of x over 2 cosine of x. Okay, and that is less than 1. Okay. Let's see. Okay, so when you think about doing the limit as x approaches 0, okay, the limit as x approaches 0 of this is, is 1. Oh, this is really dumb. Yeah, so this is actually a lot easier than you think. So when you take the limit as x approaches as x approaches 0 of this, it's 1. So then if we take this right here, it's already been defined, right? That x sine of x is less than 1. That was given to us. So if that's in the middle, then that means that this one has to be equal to 1.
Yeah, I thought so, but it was like
Sine of x over x. Okay, so the thing is that when you look at this, the tendency for you guys would be to say, oh, that's equal to 1, that's equal to 1. But why is that not equal to 1?
Because you got the 2 right there.
Well, no, but why? I'm saying why is this
The
part not
infinity.
equal to 1? Because it's to infinity and not to 0. Right? If it was limit as x approaches 0, then yes, that would be 1. But because this is infinity, that rule doesn't apply. So when you look at this, the sign of infinity is undefined. But because there's an infinity on the bottom, that will supersede this, because no matter what our sign is on top, understand, remember, sign goes between 1 and negative 1, 1 and negative 1, 1 and negative 1 forever. But it doesn't matter, because if you're going between 1 and negative 1 and you're over a ginormous number like infinity, that is just going to be 0. So the limit there will still be 2. Does that make sense? If I were to just simply put an x there, so I know that x wasn't there before, so I need to compensate for that x by putting an x here as well. The point is by doing that, I haven't changed the problem at all, because there's 1 on top and 1 on bottom, and the limit of this is going to be 3 over 1, and the limit of this is going to be 1 over 5, so your answer is just going to be 3/5.
It's cosecant minus 1 equals cotangent squared.
Yeah, right. So cosecant squared minus 1 is equal to, yep, so this right here and this right here ends up being cotangent, so your final answer is 2 cotangent squared of y. And you're not using any of these up here because we're not dealing with any y's up here.
You'd only use these triangles up here if you're using A or B. Those are good questions. 7. Negative 25 over 7.